In this video, we are going to be covering a topic that you guys have requested quite often, and it's basically sketching trigonometric graphs. Now, I have made a video on this that was quite a long time ago. I'll share a link to it in the description box. You guys can go check it out. In that video, I've just covered the very basics, and in this video, I'm going to be doing some past paper questions. And before we start, there is a feature in the calculator that I'm going to be using very often, and I'd like you guys to use it also. So if you want to learn that first, I'd suggest you go check out you go check it out that video. And there's something else I posted on my Instagram also, which I will make sure that I attach in this PDF. That's sort of like a summary of all the trigonometric graphs and what you need to do in order to find out the period, the amplitude, the step. Again, that's something that we're going to be needing to basically find out. I mean, that's something that we're going to be finding out so that we know how exactly make use of the table feature in our calculator. Anyway, so I'll give you guys a quick intro of all three graphs actually. So over here I've made y equals to sine x, and again this is basically from my online classes that I was taking last year. So this is what a sine curve looks like, and you can see that I've plugged in values after taking an interval of 90 degrees, and that's exactly what you do when the coefficient of x is 1. As you can see here, it's y is equals to sine x, and this is what a sine curve looks like. So at 0 it's 0, you can see at 90 it's 1, at 180 it's 0, at 270 it is minus 1, and at 360 it's 0. And this is what y equals to sine x looks like. The maximum value is 1 and the minimum value is minus 1. The amplitude is 1, and the period, by the way, which I should mention, the natural period is basically the number of degrees it takes a curve it takes a graph, whether it's sine or cos or tan, to complete one cycle. So the natural period of sine and cos is 360 degrees, because at 360 degrees one cycle completes, and from that point onwards you start getting the same thing over and over again. Again, something that I've recently posted on my Instagram, so I strongly suggest you check it out and save it, write it down, whatever. It's gonna come in very handy for the exam that students are preparing for October, November. You guys probably have an exam tomorrow. I mean, not probably, for sure have an exam tomorrow, so very handy for you. Okay, so then we have y equals to cos x, and this is what the curve of cos x looks like. So basically, what you need to do is you need to be extremely well familiar with the basic shape, because everything that we're going to be doing is just tweaking this shape. Okay, so you need to be well versed with what the basic shape of sine, cos, and tan is, what the natural period is, what the natural step is. By that I mean what is the difference or the interval after which we plug in each and every single value. So stuff like that, that's something you should be extremely familiar with. And once you're well versed with that, then everything else becomes a piece of cake. And then you can see here that what I've done is I've multiplied y equals to, we've made a graph of y equals to 2 sine x. Again, I've color coded it, and then y equals to minus sine x, so all the values get multiplied by minus, and then you have y equals to sine x plus 1. So you draw the graph of sine x and then shift it 1 unit upwards. And I've written all the formulas here. So now this is one graph that I want to focus on. It's the graph of tan, and this is the graph that most of you have requested in particular. So the graph of tan is actually not that difficult. I know this looks with all the infinite values and all that, it just looks creepy, but it's not. So here's how the graph of tan starts. At 0 it's 0, and in tan, one thing that you have to remember is that we take the step of 45. In sine and cos, you can see that I was taking values after an interval of 90 degrees, but with tan we take it with 45. That is if it's tan x. If it's tan 2x, 3x, 4x, or something else, then that also changes, and we'll find out what happens to that. And then at 90 it becomes infinity. Now this is an interesting concept. If you were to plug in a value of tan, let's say 89.9, you would still get a value, but the second it becomes 90, it becomes infinity. And that is why at 90 and at 270 we draw these things called asymptotes. They're basically infinite dotted lines that the graph approaches but doesn't touch or intersect, for that matter. And then from that point onwards, from right after 90, if you find out tan 91, you'll notice that it's an extremely negative value. And you can see that right after 90 degrees, tan starts from a very negative value, and that at 135 it's minus 1, at 180 it's 0. And this is the point where one cycle completes. And if you're allowed to make the graph up until 360, So that means you will end up making another cycle. Now, there's a misconception that students think that whatever the coefficient of x is, that's the number of cycles you need to draw. That's not always the case. Sometimes, yes, it just happens in such a way that whatever the coefficient of x is, you end up drawing that many cycles, but that's not a general rule, as we'll find out once we're doing some full-length past paper questions. Anyway, so these are some key points that you got to keep in mind. And again, the PDF that I was talking about, I've attached it in this. If I haven't, yeah, this is the PDF that I mean, this is the Instagram post that I was talking about. This is something I should have with you at all times, and this will something you can refer to when you're making graphs or whatever it is. You have basically two type of questions. One is that you may be given a graph and you may be asked to find the amplitude, the period, and the shift, which is basically the value of c. The other is that you will maybe asked to sketch the graph and show what that looks like. So anyway, let's get to work and see. Let's do a couple of past paper questions that I have lined up for you guys. And here's one question. Let's see what it says. So it says, write down the amplitude of 4 sine 3x minus 1. Now, if it's sine, cos, and tan, whatever the value that you have right before the function, okay, that is the amplitude. So over here, what you have is 4. So you can see it's just a 1-mark question, no working required. So the amplitude straight away is going to be 4. Okay, and I'll tell you what you have to do when you're given the graph, and then you have to, when the graph is already made for you, and then you have to work out the amplitude. So I'll tell you that when we come across a question. Then it says, write down the period. Okay, now why exactly is it asking us for the period? Don't we already know that the natural period is 360? Yes, we know that the natural period is 360, but that is only when y is equals to sine x. So when y is equals to sine x, the natural period is equals to 360 degrees. But what if when y is not equal to sine x? What if it's equal to sine 2x or sine 3x that we have over here? In that case, your new period is going to be equal to 360 divided by b, and b we normally take to be the coefficient of x, which in this case is 3. So that's exactly what I'm going to do. I'm going to take 360 and divide by 3. So we're looking at 120 degrees. Now, what exactly is this 120 degrees representing? This is telling us that the cycle will complete after 120 degrees. Okay, so that's something you got to keep in mind. Okay. Then it says, on the axis below, sketch the graph of y equals to 4 sine 3x minus 1 for minus 90 to 90. Okay, now this is the point where you should make 100% use of the table feature in your calculator. Again, I made a detailed video on it. I'd suggest you go check it out if you haven't, and then come back to this video. Although I will try and explain how you can, I'll try and explain this over here also. So the second you press the mode key, you'll see table written somewhere. In my calculator, it's at 7, so I'm going to hit 7. And then it's saying f of x equals to, all right, this is what I see. I hope you guys can see it. And then over here, I'm going to type the exact function that I'm dealing with. So 4 sine. And make sure that your calculator is in degree mode, because over here, x is in degrees. And then inside the bracket, I'll have 3x. And yes, you'll write x with using the alpha key. Okay, so hopefully you can see what I've done here. And then don't forget that there's a minus 1. So just before I press equals to sign, let me show you what this looks like. Then you press the equals to sign. Now it's asking you where to start from. Okay, you will see start with a question mark. This is what you guys should see. And if you have a Casio classless calculator, then it's going to be asking for g of x equals to. So the good thing in that calculator is that you can find out the values of 2 separate functions. But if that happens to be the case, if that's a calculator that you have, then you can skip that by just pressing the equals to sign. Anyway, now coming back, it's asking us where to start from. So this is the point where we start, all right, wherever x is starting from. So I'm going to hit minus 90, press equals to. Then it's asking us where to end. So this is the end value. So again, I'm going to hit 90, press equals to. Then it's asking us for the step. Okay, now you can see it's already written 1, or maybe something else, given that if you've done a question before. So here's how you're going to work out the step. Now, the natural step that we take for sine is 90, as you saw earlier. This time, however, our new step, just like we have a new period, we're going to have a new step, is going to be 90 divided by 3. So 90 divided by 3 is equals to 30 degrees. So I'm going to press 30 and press equals to. So once you do this in your calculator, it becomes a whole lot easier. And it's just that you have to do this once, and then you get all the values, as you can see here. As soon as I entered the step, I'm just waiting for it to focus. Yeah, so you can see that I have all the x values on the left hand side. Yeah, left hand side, and all the y values on the right hand side. So it's telling me that at minus 90, y is equals to 3, Okay, so here's 1 point. Then it's telling me at minus 60, y is equals to 1. Okay, then it's telling me that at minus 30, y is equals to minus 5. So it's going further down. And then at 0, it's equal to minus 1. And then at 30, it's equal to 3 again. At 60, it's equal to minus 1 again. And at 90, it's equal to minus 5 again. So there you go. Here's minus 5. All right, let me just double check before I plug in. At minus 30, actually at minus 30, it was minus 5. Yeah, so just realized I made an error there. At minus 30, it's minus 5. There you go. Okay. Let me just double check. Minus 30 starting from minus 90. Minus 90 is 3. So far, so good. Minus 60 is... Okay, so now I'm just gonna mark all the values. So starting from minus 90, at minus 90 it's positive 3. So 1, 2, 3. So you can see that I'm marking all the points. At minus 60 it's minus 1. So there you go. At minus 30 it's minus 5. So there you go. And then scroll down for the other values. At 0 you'll see minus 1. At 30 you will see 3. At 60 you will see minus 1 again, and at 90 you will see minus 5 again. Okay, so I've marked all the values. Now is the time that I'm going to make the curve, sketch the curve. And when you're sketching a curve, remember that's a freehand curve, okay? Even though you'll realize that these 3 points fall in a straight line, but that does not mean that you make a straight line, okay? Again, like I said, you need to be well familiar with the general shape of sine curve, and that's what this needs to follow. Okay, so this is it, the moment of truth. Okay, I can do better than that. So at 0, this was equal to minus 1. So let me just mark that again. There you go. Whoopsie, sorry about that. That's that, and we get our 3 marks. Now, one thing I should mention is that if you don't want to use this table feature in your calculator, or you think it's too late to learn something new, then you can always work out the new step like we just did, and then you can manually program you can manually plug in the values and find out. Like for example, if I didn't want to use this, I would start at minus 90. I'd plug in minus 90 and 4 sine 3x minus 1, and then I'd increase that value by 30 degrees, and so the next value I'd plug in would be minus 60, and then minus 30, 0, so on and so forth up until I get 90. I'll mark all the values, and then I'll just sketch the graph. Okay, but that is if you don't want to use it. Although I would strongly suggest that you do use it. It saves a lot of time, and you can be 100% sure about your answer. Now here's another question that I want to solve for you guys, and this I should mention is from Major 2021, Paper 1, Variant 4. So it says here, on the axis below, sketch the graph of y equals to 6 cos 2x minus 1, okay, for 0 to 360 degrees, all right? So again, I'm going to make full use of my calculator, so I'm going to hit the table mode, and 6 cos 2 alpha x, bracket close, minus 1. So we're going to start from 0, end at 360. Now this time the new step that we're going to take is not going to be 90. In fact, it's going to be 90 upon 2. That means it's going to be 45 degrees. So step 45, and we have the values. So at 0 we have minus 5, so that means minus 4 is going to be somewhere over here, so minus 5 is going to be somewhere over here. So 0 minus 5, there you go. I'm marking all the values in blue. And then at 45, now I should probably mark 45 here, and then 135, and then 225, and then 315. Okay, now at 45 we have minus 1, so that's going to be somewhere over here. At 90 we have minus 7. Oh, by the way, at 0 we didn't have minus 5, we had positive 5, so that's going to be somewhere over here. So positive 5 is going to be somewhere over here. Yeah. And then at 90 we have minus 7, so that's going to be just above minus 8, so probably somewhere over here. At 135 it's going to be minus 1, so that's going to be just in line with the value that we had at 45. At 180 it's going to be 5, so we're back at 5. And then at 225 it's equal to minus 1, so again in line with the previous two values. And then at 270 it's equal to minus 7, so again in line with the value we had at 90 degrees. And then at 315 it's back at minus 1, At 360, it's back at 5. So again, in line with the previous two values. Now, you can see here, by the way, in fact, let me sketch the entire thing and then show you guys, point out something that is worth noticing. So that's one cycle. Gonna make another one. There you go. Now, you can see here that we have how many cycles? We have 2 cycles. Now, that's not because the coefficient of x is 2. That is entirely because this time the new period would have been 360 upon 2, which is equal to 180 degrees. And the range of x is such, since it's from 0 to 360, we can accommodate 2 cycles. Since one cycle ends at 180 degrees, so we can go another cycle, which is why you have 2 cycles. Okay, so there's this misconception that the number of cycles is always equal to the coefficient of x. That's not always the case. It coincidentally may be like we have over here, but not always. Okay, now here's another type of question that I really want to solve with you guys. It says the graph y equals to a plus b sine c theta for minus 180 to 180 is shown below. Write down the value of each of the constants a, b, and c. Now again, as I mentioned previously, you should be very well familiar with the curve of sine and cos, sine, cos, and tan. Now, the first thing I want to find out is, and you don't necessarily have to follow the order, is the amplitude. Now, normally we take a sine b theta plus c, but I don't want you to just memorize it like that. It's because the question may just jumble it up, and that's exactly what the question has done here. So first thing I want to do is I just want to write it nicely so I can see what the amplitude is, what the coefficient of the angle is, and what is the value that's going to cause the vertical change here. Okay, so this is what it's going to look like. So b, remember, is the amplitude. All right, c will be how far up or how far below the curve has shifted, and c is basically equal to b, right? What we normally take as b. Now, let's start with the amplitude. Now, the formula for calculating the amplitude is maximum value minus the minimum value divided by 2. So that's exactly what I'm going to do. The maximum value you can see is 4. The minimum value is minus 4. So if I want to work out a, here's what I'm doing. 4 minus minus 4 upon 2 is equal to, sorry, not a, but in fact b. So 4 minus minus 4 is 8. 8 upon 2 is 4. That means b is equals to 4. So we're looking at the value of b, which is equal to 4. Now, as far as the period is concerned, you can see that this curve is ending one cycle at exactly 360 degrees. So it starts at minus 180 and ends at 180. So from minus 180 to 180 is 360 degrees. So that means the new period is also 360 degrees. So the formula that we use is basically new period is equals to 360 divided by the coefficient of the angle, which in this case is c. Okay, now since the new period is also 360 degrees, so 360 equals to 360 upon c, that means c is equals to 1. So that's what c is equals to. Now a, which is the value that you're adding towards the very end, let's see what that is going to be. Now the amplitude is 4, okay, and we can see that if you look at the sketch, the maximum value is in fact 4 and the minimum value is in fact minus 4. So that means there has been no vertical shift. Had there been a vertical shift, the maximum value would have increased by a certain amount and the minimum value would have also increased by a certain amount. So if we just analyze the curve for sine theta, whatever the coefficient of theta may be, you know that it's going to start at 0, it's going to go at positive 4 and then come back at minus 4. And that's exactly what's happening here. Now, when would this have not happened? When there would have been a value that we have added or subtracted. So since it's going all the way to 4 and coming down all the way to minus 4, that means we haven't really added or subtracted anything. That means the value of a is straight away going to be equal to 0. So that's that, and here is another question that I would like to solve for you guys. This, I should mention, is from May 2021, paper 2, variant 1. Let's see what it says. So it says the graph of y is equals to 2 tan a plus 2 tan bx. Now, the first thing I'd like to do is, I should probably write it nicely. That means 2 tan bx plus a, where a and b are constants, passes through the point 0 minus 4 and has a period of 480 degrees. Okay. Now, here's what I'm paying attention to. Period of 480 degrees. Let's see how I can use this. So, new period, as we all know, as far as tan is concerned, is 180 divided by the coefficient of the angle, which in this case is also b. Now, the new period is equals to 480 degrees. So, that's what I'm going to do immediately. I'm going to replace the new period by 480. That means as far as b is concerned, all I got to do is 180 divided by 480, and I'm looking at 3 upon 8. So, the value of b is equal to 3 upon 8. Okay, now that means so far this is what our equation has become. We're looking at 2 tan 4 upon 8x plus a. Now if you want to find out the value of a, so technically in this equation we have how many unknowns? We have x, y, and a. So we have a total of 3 unknowns, and the question has been kind enough to give us the value of those, of 2 out of the 3 unknowns, and that's exactly what we're going to do. We're going to plug in minus 4 as y, and we're going to plug in, sorry, I wrote 4 upon 8, it's actually supposed to be 3 upon 8. Okay, my bad. Yeah, so anyway, it doesn't matter because 3 upon 8 times 0 is going to be 0 anyway, plus a. So we're looking at 4 is equals to 2 tan of 0 plus a. So tan 0 is 0 because that's where the graph of tan starts from. At 0, it's 0. Multiplying it by 2 is not going to make any difference. So that means a is equals to minus 4. And let's see what we're looking at. We have the value of a also. So let's just put it in a box. And there you go. That's your final answer. Okay, now over here it says, on the axis, sketch the graph of y for values of x between 0 and 480 degrees. And let's see how many marks do we get for this. We get 2 marks. So just because it's 480, not a number that you're used to not a number that you're used to dealing with, doesn't mean that you start freaking out. And just because it's tan doesn't mean that you need to start freaking out. It's actually very simple, given that you remember the step to take and the new period and all of that. Okay, now one thing to keep in mind is that during this, in this 480 degree interval, we will just be making one cycle because that's what the period is, and that is also what the range is. Okay, now what we have to do is we need to find out what the new step is. Now first thing in fact is I'm going to complete the equation. So y is equals to 2 tan 3 upon 8x minus 4. So this is the equation that I'm going to be plugging in my calculator. Now I'm going to start from 0, go all the way to 480. The step that I'm going to take, however, is the following. So normally the step for tan is 45, but this time I'm going to take 45 and divide by 3 upon 8. So let's do this right now. 45 divided by 3 upon 8 is equal to 120 degrees. So that's what I'm going to do. I'm going to plug in values after 120 degree interval. You can do that manually or you can use your calculator. I would strongly suggest you use your calculator. So 2 tan fraction inside the bracket 3 upon 8 alpha x bracket close minus 4. So start at 0, end at 480 please, and take a step of 120 degrees. Okay, so here's what we're looking at. Now one thing I probably should have done first is mark the values. So 2, 4, and 6, and just like that, minus 2, minus 4, minus 6. It's a sketch, but again, try and be as accurate as possible. So at 0, we're looking at minus 4. At 120, we are looking at, again, one more thing that I should have marked is between 480 and 0, we'll have 240, and between 0 and 240, we'll have 120 degrees, and between 240 and 480, we'll have 360 degrees. Yeah, okay. So here's what we're looking at. At minus 4, it's 0. At 120, we're looking at minus 2. At 240, we're looking at an error. So that means when it's 240, our graph goes towards infinity. So how do I show that? I show that by making a dotted line at 240. And before you proceed further, if you look at the other values, just to make sure that all the values are, none of the values are going beyond minus 6 or positive 6. Yeah, so none of the values are going beyond that. So, there's no need to mark the graph any further. Anyway, so at 240, our graph is going to go towards infinity. So that's what we're going to do. And at 360 degrees, the graph is at minus 6. So the y value is minus 6. And at 480, we're back at minus 4. And that is where our cycle will end. Now I'm going to extend this line because I need to show that it's coming from negative infinity, and I'm going to extend this further because I need to show that it's going all the way to positive infinity. Okay, so here's what I'm doing. So make sure it's nice and smooth, and you got to show that the closer you get to 240, it goes towards infinity. And then right after 240, it's going to start from negative infinity. At 360, it's going to be what? I think minus 6. Yeah. And at 480, it's going to be minus 4. And there you go. So, like I said, nothing too scary, not too difficult, given that you know what values to plug in and, you remember the general shape of the curve. So, and you get how many marks? You get 2 marks for this. So 2 marks that you guys can very easily earn. Okay, so here's one question where we're going to be dealing with radian, and this I should mention is from Major 2018, paper 1, variant 1. Okay. So it says here the curve y equals to a sine bx plus a plus b sine cx has an amplitude of 4 and a period of pi by 3, given that the curve passes through the point pi by 12 and 2. So the first thing I want to do is that I want to turn my calculator into radian mode before I do anything else at all. Okay, now as far as amplitude of 4 is concerned, that's what the value that you have just before the trigonometric function, or that's what the trigonometric function is multiplied with. So we can see that this sine function is being multiplied by b. So right off the bat, b is equals to 4, no questions asked. And then period of pi by 3. Now remember, we're dealing with radian here, okay? That means now the natural period is not going to be 360. In fact, I mean, it's still 360, but we're not going to call it 360. We're going to say 2 pi. So the new period is going to be worked out by taking 2 pi and dividing it by the coefficient of x, which in this case is c. So I'm going to replace the new period by pi by 3. So pi and pi get cancelled out, and we're looking at c is equals to 6. So we have the value of c also, we have the value of b also. Now let's save some space here. So I'm going to move this over to the left hand side. Okay, now so far this is what my equation looks like. I'm looking at y is equals to a plus 4 sine 6x, and again, how many unknowns do we have here? I have x, y, and a. And just like we did previously, we're going to plug in this point because we're given the value of x and the value of y. So y is equals to 2, a as it is, 4 sine 6 times pi upon 12. So 6 pi upon 12. Okay. So I'm going to use my calculator for this. So the first thing I'm going to do is I want to work out what 4 sine pi 6 pi divided by 12 is. So let's work that out. So we're looking at 4, and then 2 is equals to a plus 4. That means a is equals to minus 2. And there you go. You have the value of a also. Make sure that you show all this working so that you can get the 4 marks that you're supposed to. Okay, now this is the interesting part. Over here, you have to sketch the graph of y is equals to a plus b sine cx. And what I'm going to do is I'm just going to complete the equation. So 4 sine 6x minus 2. You can see that I've written 4. I've rearranged this. So just so that it makes it easier for me to plug in, because this is the way that we're normally used to dealing with equations of trigonometric graphs. Okay, so enter into the table function. Again, make sure that your calculator is in radian mode. If you haven't done that, you can do it now. So 4 sine alpha x bracket close. Now one thing that I should have figured out is the new step. Now the new step is basically going to be equal to 90, but this time we're not going to take 90, we're going to take pi by 2, and then we're going to divide it by 6. So that means we're looking at pi upon 12. Now before you use the table mode in your calculator, what you want to do is you want to get familiar with your grid, okay? Because if you're not too familiar with your grid, then it's just going to make it more difficult for you. Now how can I get familiar with my grid? So here's what I can do. Now you can see that it goes from 0 to pi, okay? That means exactly in between I'll have pi by 2, or half pi. Now that's not enough. I also want to know that how many units is this one horizontal block, you can say, representing. So how do I find that out? Well, so what I'm going to be doing is, for now, I'm just going to be ignoring pi, and I'm just going to be dealing with the fraction. So you can see here that pi by 2, or half, like I said, I'm going to be ignoring pi, has been split into 3 boxes, okay? So here's what I'm doing. I'm taking half and I'm dividing it by 3. So that means every little box here, every little box horizontally is responsible for 1 upon 6 pi. Now what I'm going to do is I'm going to take 1 upon 6 and I'm going to add 1 upon 6 to it, so that I know what value do I have for the other block. So I'm looking at 1 upon 3, and then I'm going to put a pi right after it. And then if you add 1 upon 6 pi to 1 upon 3 pi, you'll get pi upon 2. And then I'll add 1 over 6 here, I'll add 1 over 6 here, and then I'll add 1 over 6 here, and hopefully I'll get to pi. Okay, so 1 divided by 2 plus 1 upon 6. So I'm looking at 2 upon 3 pi, 2 upon 3 pi, and then 2 upon 3 plus 1 upon 6. So I'm looking at 5 pi by 6, 5 upon 6 pi. And then if you add 1 upon 6 to 5 pi by 6, you will get to pi. Okay, so this is something you need to do beforehand. You need to get yourself familiar with your grid, and if you don't do that, then you're just going to end up in trouble. And as far as the y-axis is concerned, you can see that you have 6 divided into 3 boxes, so that means every box is responsible for 2, and same goes for below 0. And another thing that you want to do is notice that our step is basically pi by 12. That means we're going to be plugging in values starting from 0, and then the next value that we're going to plug in is pi by 12, okay, which is going to be exactly in between 0 and 1 upon 6 pi. And then the next value that we're going to be plugging in is 1 upon 6 pi, and then the next value that we're going to be plugging in is going to be in between 1 upon 6 and 1 upon 3 pi, and that's how we're going to be plugging in values. So whenever you're marking, make sure that you start from 0, and then the next value that you mark, the x coordinate is between 0 and 1 upon 6 pi, and that's how you should proceed, so on and so forth. Okay, now, here's what I'm doing now. This is a point where I use my calculator, and I enter into the table mode, and I'm looking at 4 sine 6 alpha x, bracket close, minus 2. I'm going to start at 0, and I'm going to end at pi, so make sure that you write pi as it is. And then the step this time is going to be pi divided by 12. And there you go. We have all the values. Now at 0, we're looking at minus 2. One thing that I would suggest is that you count the number of values that you have, just so that you don't want to get lost in all the decimals. You count the values that you have. So we have a total of 13 values to mark, okay? Now what that basically means is, now get an idea of those 13 values. So the first value is at 0, okay? So that's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. So these are the 13 values that we're going to mark, okay? Now this is something that if you do this beforehand, then the chances of you getting lost, because things can get confusing when you're dealing with radian, but again, if this is a drill that you do beforehand, you will hopefully not get lost. So at 0, we're looking at minus 2, so that's great. And then the next value, right after 0, we're looking at 2. And then the value after that, which is 1 upon 6 pi. Again, I don't see it as 1 upon 6 pi, but since I know I've taken the interval as pi by 12, so I know this has to be 1 upon 6 pi. So now I'm looking at minus 2 again. And then I'm looking at minus 6. So that means the value between 1 upon 6 pi and pi by 3 is minus 6. Sorry, not minus 4. So let me just mark that again. Yeah. And then right after that, I'm looking at minus 2 again. And between 1 upon 3 pi and pi by 2, I'm looking at 2. And then at pi by 2, I'm looking at minus 2. And then in between that, I'm looking at minus 6 again. And then after that, I'm looking at minus 2 again. And you've probably picked up a pattern by now. And then at 5.6 pi, I'm looking at minus 2. And at the second to last value, the 12th value, I'm looking at minus 6. So there you go. And then the last value, finally, I'm looking at minus 2. So we're back at minus 2. Okay. Now this is it, the moment of truth. This is where we join all these points with the help of a nice and smooth curve. Oopsie. So there you go. So there you have it. We have officially completed this question. Yep, there's no other part to it. And again, I will encourage you guys to attempt the remaining questions and go through the notes. They're in detail. They definitely help you out. And hopefully you've gotten the hang of sketching trigonometric graphs by now. So that's all for this video. I will see you guys in the next video, inshallah, whenever that is. So take care. Good luck to you for your exams once again. Bye-bye.